Welcome to Episode 7. Define cardholder and sensitive authentication data precisely. The promise today is crisp, working definitions that remove doubt about what must be protected, what must never be stored, and how those choices shape scope and controls. When words are sharp, actions become straightforward, because teams can point to a field on a screen or a column in a file and agree on its treatment without debate. We will keep our pace slow and accurate because precision in terminology is the lever that moves everything else in the payment card industry. Clear names turn into clear handling rules, which turn into evidence that actually satisfies an assessor. By the end, you will be able to hear a data element, classify it out loud, and say the next step: retain, redact, render unreadable, or reject, without hesitation or hedging. Cardholder data, usually shortened to CHD, centers on the primary account number, which we will state fully once as the primary account number, PAN, and then treat as the anchor of classification. CHD includes the PAN by itself, and it also includes combinations where PAN appears with the cardholder name, expiration date, or service code. Those companions make records more useful for business, but the presence of PAN is what pulls the record into scope and demands strong handling. Think about a concrete acceptance moment to fix the definition in your mind. A countertop device reads the card, a gateway returns an authorization, and your order management system receives only the first 6 and last 4 digits for reference alongside the customer's name and order number. In that picture, the PAN is the bright line you never cross in storage unless it is rendered unreadable. And the masked view in your order tool is a display convenience, not a license to keep full numbers anywhere else. Say it plainly. If PAN touches it, it is CHD, and CHD brings controls with it. Sensitive authentication data, shortened to SAD, names the elements that enable authentication and must never be stored after authorization, not even if encrypted. Typical SAD includes full track data from the magnetic stripe, or its equivalent on a chip, CAV2 or CVC2 or CVV2, or CID values printed on the card, and any PIN or PIN block used for verification. These items are powerful because they prove card possession or authorized transactions. That is why the rule is absolute after authorization. Before authorization, certain secure processing paths may handle them transiently, but design should keep them out of general systems and logs, and controls must ensure they disappear on schedule. A safe way to speak this into habit is to pair the bright words never and after authorization in the same sentence. You can process SAD in the narrow, secure channel that needs it, and then it must be gone without exception. An assessor will not debate your intent. They will ask to see that it cannot be recovered anywhere you operate. Masking, truncation, and rendering unreadable often get conflated, so draw clean lines between them, then add strong cryptography on the right side of the line. Masking is a display practice that hides digits from view, such as showing only the first 6 and last 4 in a user interface, so on the screen it looks like asterisks in the middle. Truncation is a storage practice that removes part of the number so the full PAN cannot be reconstructed in that record, which is why acceptable truncation patterns exist that still allow internal reference without recreating the secret. Rendering unreadable is stronger than both and means that if you store the full PAN, it must be protected by a method that makes it computationally infeasible to recover clear text without proper keys or secrets, combined with key management that prevents shortcuts. Strong cryptography is the way to achieve that last state, and it comes with duties beyond turning a feature on. You must own keys, rotate them with discipline, separate duties, and prove the configuration lives as designed. If a system only masks display but stores full clear text underneath, you have not rendered anything unreadable. You have just dimmed the lights. Storage prohibitions for SAD deserve repetition because they are easy to violate by accident and expensive to correct later. After authorization, SAD must never be stored. Not in databases, not in log files, not in screenshots or support tickets, not in attachment folders, not in backup images, and not in analytics extracts. The word never applies even when encryption is available, because the rule is not about how hard it is to read, it is about forbidding retention that would allow misuse. During authorization, the safest path is to confine SAD to components designed for that short window, ensure memory and buffers are cleared, and prevent debug logging from capturing contents. Good programs go further and remove SAD from developers' line of sight entirely by using test data and masked traces, because human convenience often becomes the backdoor for violations. The point is simple. SAD does not belong in places where business processes take root, and controls should make wrong placement impossible rather than merely discouraged. Display needs and storage needs diverge, and least privilege viewing keeps the divergence from becoming a leak. Many business workflows require someone to see a partial pan to locate an order or assist a customer, which is why masked views are common in tools used by support and finance. The rule of thumb is that display shows no more than it must, while storage keeps nothing that a display mask already hides, and neither grants access to people who do not need it to perform a defined task. Viewing rights should follow roles, and they should be logged, reviewed, and periodically pruned, because stale visibility is a slow leak you only notice when your evidence is challenged. The best implementations link the visible mask to the user's role, so that a broader mask shows only for those with a documented need and organizational sign-off. This separates curiosity from duty cleanly. Under assessment, you will be asked who can see which digits and why, and a good answer names a role, a ticket, and a review date. Logs, tickets, and screenshots are where good intentions often die, so map typical data elements and state redaction duties out loud. Infrastructure and application logs should never capture full PAN or any SAD. Configure logging frameworks to filter request bodies, truncate numbers, and drop fields entirely when necessary. Help desk tools should present masked PAN by default and should confine attachments to redacted images only, with guidance that forbids uploading raw exports just this once. Screenshots used for troubleshooting must be edited to remove any sensitive digits before they leave the secure environment, and any automation that collects diagnostic bundles must be taught to exclude sensitive paths. Ticket comments, chat transcripts, and email threads all count as storage when they persist in systems you back up, which is why written procedures should replace "be careful" with "the system blocks it" where possible. Evidence will include samples of each medium, and your redaction policy becomes meaningful only when the sample shows it working without drama. Tokenization changes the geometry of risk, but it does not erase obligations blindly, so learn to talk about outputs versus originals. A well-designed tokenization system replaces PAN with a token that cannot be reversed by anyone without access to the secure vault, and that token may be safe to store widely if it carries no exploit value on its own. Systems that receive only tokens and never touch clear-text PAN can often sit at the edge of scope or outside it, provided the architecture prevents backdoor retrieval and the token cannot be used to impersonate a card elsewhere. However, systems that operate the tokenization service or hold the keys to map token back to PAN remain firmly in scope, and any interface that allows detokenization must be guarded by tight roles, logging, and review. The responsible way to speak about tokenization is to say where cleartext lives, who can reach it, and how that is proved over time. When you can say those three things cleanly, scope decisions become defensible instead of hopeful. Hashing and encryption both fall under rendered unreadable, but the bar for safety is not the same, and the choice matters. Encryption uses keys to turn clear text into ciphertext and back again under control, so the strength of the algorithm, the quality of the keys, and the discipline of key management decide your safety. Hashing turns a value into a fixed-size digest that cannot be reversed in theory, but simple hashes of PAN are notoriously weak in practice because the input space is small enough for pre-computed tables and guessing attacks. To rely on hashing for protecting stored PAN, you need designs that add secrets, such as keyed hashes or salts, and that keep those secrets guarded with the same care you would give encryption keys, plus controls that prevent easy verification by attackers. A clean mental rule is that encryption with strong key management is the default for full PAN at rest. Truncation is valid when business can live without the whole number, and specialized hashing schemes require rigorous design and review before anyone calls them safe. A rushed hash is not protection, it is a to-do list for an attacker. Take a scenario and classify it carefully, because practice with mixed fields builds confidence for audits. Imagine a database export pulled by a reporting analyst that includes customer name, email, masked pan showing first 6 and last 4, full authorization codes, order totals, shipping addresses, and a column labeled track data that, on inspection, is empty for most rows but contains long base 64-looking strings for a handful. The masked pan in the report is display only and does not make the file CHD by itself. But if the source query ever allowed full pan, the export process needs proof of truncation at the query or view layer, not just in the presentation tool. Authorization codes are fine, they are not SAD. The track data column is a red flag. Even if most rows are empty, any presence of magnetic stripe equivalent data would be SAD and would violate storage bans if it survived post-authorization. The right response is to strip that column at the source, validate that upstream systems do not populate it, reissue the dataset, and document the fix. An assessor would expect to see the corrected schema, sample rows, and a change ticket with dates and sign-offs. Pitfalls repeat across organizations, so keep a mental shelf of silent leaks that create SAD or full PAN storage without malice. Backup images can freeze violations in time and carry them forward for months if pre-clean files slip into nightly jobs, which is why you verify data hygiene before inclusion and confirm backup retention and encryption on media. Support emails that ask customers to send a picture of the card or to confirm the 3 digits on the back create prohibited storage in mailboxes and archives. Your scripts must forbid such requests and route identity checks to safer methods. Chat transcripts can capture entire form fields when a customer pastes content, so filters must block those patterns and warn both sides before the text lands. These are not edge cases, they are Tuesday. Your program only becomes resilient when systems stop accepting SAD and staff stop believing temporary makes a rule disappear. The exam favors answers that treat these places as design targets, not scolding opportunities. A quick test helps you decide whether a data element triggers extra controls immediately, and it works because it is brutally simple. First, ask whether the element is PAN or contains the full PAN. If yes, you either do not store it or you render it unreadable at rest and confine access by role with logs and reviews. Second, ask whether the element is SAD track contents, card verification values, or PIN data. If yes, you never store it post-authorization and you verify that systems cannot capture it by design. Third, if the element is neither but appears in artifacts like logs, tickets, or screenshots, you apply redaction rules that prevent full PAN from showing and you ensure tools block SAD entirely. Say the 3 questions aloud when in doubt. They are not clever, but they are reliable under time pressure and map exactly to what an assessor checks when they sample your evidence. A short mnemonic can glue the categories together so they surface on command. Try name the core, guard the keys, refuse the secrets, and blur the rest. Name the core reminds you that PAN defines CHD and that anything with PAN becomes a control subject. Guard the keys reminds you that encryption and key management live together and that rendered unreadable means both algorithm and custody. Refuse the secrets reminds you that SAD must never be kept after authorization, no matter how neat the feature or how tight the budget. Blur the rest reminds you that displays, logs, tickets, and screenshots must mask, truncate, or redact so that only the minimum needed for business is ever visible. When your mind goes blank, say the 4 lines and let them pull the right rule to the surface. A memory that speaks is a memory you can trust when the clock is loud. Turn those ideas into a desk-side script you can use today, especially for rejecting SAD in live support interactions with Grace. The script begins before the customer speaks by placing clear language on forms and in prompts that says you will never ask for full card numbers, verification codes, or PIN values, and that any such messages will be declined for safety. When a customer offers SAD anyway, you respond with a steady sentence that explains you cannot record or retain those details, and you guide them to the accepted channel, such as the secure payment page or an in-store device. Your system should reinforce your words by blocking entry into the ticket, removing attachments that contain sensitive patterns, and logging the event as a prevented risk. And with a brief confirmation that the secure step is complete and that no sensitive data remains in the conversation record. The script protects the customer, protects you, and creates evidence of a culture that refuses risky shortcuts. Bring the episode to a close by linking precision in definitions to power in decisions. You now hold working, spoken lines for cardholder data and sensitive authentication data, and you can explain masking, truncation, and rendering unreadable without mixing them up. You can state why SAD is never permitted after authorization, distinguish what a role may view from what a system may store, and describe how logs, tickets, and screenshots become safe through redaction that actually works. You can place tokenization, hashing, and encryption on the same map and choose the right method based on risk and evidence. Most of all, you can decide in seconds whether a data element belongs, where it should live, and what proof will show that your decision endured. Practice your desk-side script once this morning and once tonight, and tomorrow reject the first unsafe request you encounter with confidence. Precision is not pedantic in PCI work. It is the shortest path to controls that hold up when someone checks. Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.